Welcome back, everyone. In today's video, we'll be discussing stem and leaf plots and histograms. A stem and leaf plot is a type of table which allows you to show particular classes of data and how often those numbers appear. If we take a look at this particular stem and leaf plot, we'll notice it's formed by what we call a T-chart, where we have two lines that form a T. We have some numbers over on the left-hand side. In this case, we have 2, 3, and 4 over on the left-hand side. And then on the right-hand side, we have some other numbers that are in the same row as our 2, 3, and 4. In a stem and leaf plot, these numbers right here are called the stems. And then these numbers here are called the leaves. Thus the name stem and leaf plot. Every stem and leaf plot will have a key, and that key will tell you how to read the numbers in the plot. So when we look at this stem and leaf plot here, our key says 3 to 7 equals 37, and in the case of this data, it's 37 out of 50. So you read the 3 stem, this here, is 30. And then all of these numbers here, for example, are 7, are our 1s. So we end up with 10s, so 3 10s, and in this case, we have 7 1s. Thus the number 37. So when we take a look at this stem and leaf plot, we see we have a variety of different numbers. We have 23, 27, 27 occurring twice, 37, 38, 39, 40, 41, 3 43s, 44, and 3 47s. So you'll notice when we take a look at the stem and leaf plot, each one of these leaves indicates a specific number. The stems in a stem and leaf plot are not restricted to the tens place. However, the ones generally are restricted to the ones place, or you could have one that would use perhaps decimal places like tenths or hundredths or thousandths. So for example, if I added another 2 in front of our first 2, this would now be 220, 227, and of course we would have 227 occurring twice. But for this stem and leaf plot, we're just looking at the tens. But that is another possibility. So one of the useful things in a stem and leaf plot is that it shows frequency of the data. And frequency is a word that we use to state how many times a certain item appears. So when we look at this stem and leaf plot, for example, the number 27 occurs twice, so it has a frequency of 2. 43 occurs 3 times, so it has a frequency of 3, and 47 also occurs 3 times. So each of those have a frequency of more than 1. You'll notice all of our other numbers only occur 1 time. And this appears somewhat easily in a visual form looking at the stem and leaf plot, because you can see the number of 3s or the number of 7s that occur. But for it to be more obvious, we want to take this same data and put it in a histogram. So before we move on to histograms, one final look at the stem and leaf plot. Oftentimes when you're looking at a stem and leaf plot, you may be asked, well, what's the smallest piece of data that you have? The smallest piece of data will always be this top left leaf here. So in this case, 23 is our smallest piece of data. The largest piece of data will always be the bottom right leaf. So in this case, that's 7. So 47 is the largest piece of data. And looking at this data, you can find other pieces of information. You can add all the numbers together and divide by how many numbers you have to calculate the mean. You can determine which number is in the middle by simply crossing off each small and large number and find the median. So for example, 23 is the smallest, 47 is the largest, then 27, 47, and you can continue crossing out small and large until you're left with the middle number. So in this case, the middle number would be in between 41 and 43, so the median would be 42. You could also calculate the mode by simply finding the number that occurs most often. For this set of data, there are two modes, 43 and 47, because they both occur 3 times. Now let's take a look at this data in a histogram. So here we have a histogram. And a histogram will look very much like what's also called a bar graph. There are some slight differences, but just at a glance, the bar graph and the histogram appear to be identical. Some of the differences are that in a histogram, you'll notice each one of the bars is touching the other. That's because unlike in a bar graph, the histogram's bars are representing a range of values. For example, this small purple bar here is representing all of the numbers between 21 and 25. Then the green bar next to it represents all the numbers from 26 to 30. So in this data, we're counting simply using whole values. So once you've got a number that's greater than 25, it would fall into a different bar. That's why those bars touch. The height of the bars will indicate how many pieces of data you have. For example, this purple bar, if you take a look at the y-axis, the purple bar goes up to 1. That indicates there's one piece of data. In this case, we're looking at take-home SOL scores. We have one piece of data that's between 21 and 25. You'll notice the green bar goes up to 2, meaning there are 2 scores between 26 and 30. If we look at our dark blue bar here in the center, it goes all the way over to 8, meaning that there are 8 test scores between the ranges of 36 and 40. So that's a histogram. Just like any other graph, you want to make note of the data that it's describing. This is 4th period scores from a take-home SOL test. The y-axis is always the number of items you're counting. The x-axis is always your intervals. So here we're looking at student scores out of 50, student scores from 21 to 25, 31 to 35, 46 to 50, etc. And you'll notice that each one of these intervals are exactly the same. 21, 22, 23, 24, 25. We're looking at 5 scores, 5 more scores, 26 to 30, 5 more scores, 31 to 35. Each one of those needs to be the same. Now we're going to take a look at the stem and leaf plot and the histogram for the exact same set of data and compare them and see what they look like. So now we have our stem and leaf plot from our first page and our histogram from our second page. So what we can see here is it's easy to compare the data. Now these are 2 different sets of data. This is first period's SOL scores, and this is 4th period's SOL scores. So you can see that if we were to do a histogram for the stem and leaf plot in the range of 21 to 25, we would only have 1 score within that range. So our bar would be the same, it would only go up to 1. When we're looking at student scores between 26 and 30, we would then want to count how many of those we have. And so here we see we have 2 scores from 26 to 30. We have those 2 27s. So again, we would have a bar going up to 2. Then we would want to look at scores from 31 to 35. When we look at our stem and leaf plot, we see no scores within that range. So we would have a bar that would get without, we would not have a bar there because we would have no data. And then scores from 36 to 40, you would count all of those from 36 to 40. We have 37, 30, 38, 39, and 40. So we would have a bar that would only go up to 4. And we would do that for the rest of those intervals. So we could take this same stem and leaf plot data and create a histogram that looks just like it. Now the differences are from the histogram we never get to see specific test values. I don't know what the test scores are between 36 and 40. I only know that there are 8 scores. I can't say that they're all evenly spread between 36 and 40. They may all be 40s, they may all be 36s, or some combination thereof. So the histogram does not let you look in the specifics of the data the same way that a stem and leaf plot does. For example, from a histogram, you would never know that we had 3 students who scored a 43 on the test. But what we would know is how many students we have in a specific range. So stem and leaf plots are a good way to analyze one specific group of data, whereas multiple histograms would allow you to better compare 2 different sets of data. So both stem and leaf plots and histograms allow us to see frequency, but in different ways. I hope this video has helped you, and good luck as you further your math career. See you next time.